In my last video, I taught you how to solve systems of equations using graphing and substitution. And today we're going to look at elimination and then applications of solving systems of equations. So elimination is just another method to solve the same type of problem. Once you've learned all three, then you can kind of choose which one you want to use based on the problem that you're given. So elimination involves basically adding two equations together using some algebraic manipulation. And I'll show you what I mean by that, but it's easier than you think. So this first one is really simple. Solve this system using elimination. The reason why I want to use elimination is, if you'll notice, we have a negative y and a positive y. If I were to add those two equations together, let me line them up. If I were to just add straight down like we do addition, 19 plus 11 is 30. Negative y plus y is 0. And 2x plus 1x is 3x. So the y variables eliminate. And then all we have to do is solve for x. Isn't that neat? So now we have the x coordinate, which means that I need to find the y coordinate. You can use either equation, it does not matter. X is 10 minus y equals 11. I went ahead and used the first one. That's just my habit. It really doesn't matter. And then I'm going to solve. And last step. And now I have my x and y coordinate. That is the point where these two lines intersect. You might be wondering what two lines. If I were to look at these two equations, I could get y by itself by, let's see, I could add y over and subtract 11. I could graph that. And then same thing for the next one, get y by itself. And if I were to graph those, let's see, go here, x minus 11, negative 2x plus 19. Negative 2x plus 19. Graph. A little hard to tell. There it is over here. Double tap, find intersection. Top left corner says 10, negative 1. So that means that my answer is correct. All right, look at number 5. We have negative 4x plus 9y equals 9. We have x minus 3y equals negative 6. And you realize that if we were to add these two equations, nothing really eliminates right off the bat. But if we do some algebraic manipulation, we can get it that way. So at this point, you just want to choose. Do you want to eliminate x or y? It does not matter. I can kind of see in either one a simple way we could eliminate, so you just have to pick one. So I'm just going to go with x because I don't normally do x first. I'm just going to go with x. Let's focus on the x's. This x is negative 4x, and this x is just positive x. If it had a 4 in front of it, then these would eliminate. So if I multiply this entire line by 4, then I've manipulated the equation so that I can use elimination. Now keep in mind that you have to multiply everything in the equation to keep it balanced. So my x's eliminate. We get negative 3y equals negative 15. Then divide, and we have our y coordinate. Now that we have our y coordinate, we can plug that into either equation, does not matter. I used the top equation, and solve for x. I'm slowing down so that you have a minute to work ahead if you want to. And then divide. So x is 9. That means our answer is 9, 5. So I mentioned that it didn't matter which variable you chose. Let's say that you had chosen to eliminate y instead. This is a positive 9y and a negative 3y. We can easily multiply this by 3 to make it 9, and then they would eliminate. So if you had chosen to do y, you could multiply the bottom equation by 3, the y's would eliminate, and you would end up with the same exact answer. For the sake of time, I'm not going to go over that, but if you want me to cover that, please email me, and I would be happy to do that with you in office hours. And then this one looks familiar. I believe we did it with graphing and substitution. And if you'll, actually, we're going to go over that in a second. Okay, so let's see. I'm going to do a little bit of manipulating here. I'm going to move 2x over, and I'm going to move 3x over, just for the sake of elimination. It really doesn't matter. You could leave it, but I'm just going to do that. And then I'm going to say I want the y's to eliminate, which means that I need one of them to be negative. So I have y minus 2x equals 0, and then I'm multiplying everything in this line by negative. Every single thing. So now the y's eliminate, and we have x equals negative 1. Now I can use that in either one of my equations to sub it back in. And we have our solution. Negative 1, negative 2. It says go back and look at your answers for numbers 1, 2, and 6. So let's just keep in mind number 6, our solution was negative 1, negative 2. Let's go back and look at number 2, which was actually from a previous video, but I have it here. Number 2, negative 1 and negative 2. And then number 1, negative 1 and negative 2. So we solved this system by graphing, substitution, and elimination, and we got the same solution. So think about that for a second. Why does that make sense? We solved the same system 3 different ways and got the same answer. If you think about it logically, well, if it's the same exact system, then it's not going to change. It's not going to change the answer depending on the method you choose, which means that it does not matter which method you choose. You just pick whichever one you're comfortable with. You can pick any method you like. It's your choice. Even if on the homework, if it says use substitution, if it's, if it doesn't ask you for the steps to solve it, then if you don't want to do substitution, you can use elimination or you can use graphing. That is your choice. I'm not going to specify on a test which one you have to use, so you just choose which one you're comfortable with. And that is going to be helpful in these next couple examples. These are applications of systems of equations, and you can it's a little more freelance. You can kind of choose how you want to set these up. I'm going to show you the algebraic way to do this and probably what you'll see in textbooks. So we're finding the value of two numbers if their sum is 12 and their difference is 4. You can probably figure that out just off the top of your head, but for the sake of learning this lesson, I'm just going to show you how you could do that algebraically, because part of the advantage of algebra is it shows you concrete ways to solve difficult problems. So we're starting small, and if you go on to trig or calculus or engineering or something like that, then you can take these simpler methods and apply them to harder things that you learn later on. So I'm going to call x my first number and y my second number. You don't have to use x and y. You can use a and b or y and z or x and r. It does not matter. They're just letters. They're just variables used to represent values. So it says, find the value of two numbers if their sum is 12. What does sum mean? It means you're adding. And their difference is 4. What does difference mean? It means you subtract. So the sum of the two numbers is 12, and the difference of the two numbers is 4. So I have these two different equations. I'm trying to find x and y, so I can use a system of equations to solve. You could use substitution, graphing, or elimination. I am going to use elimination because I have a positive y and a negative y. So we get 2x equals, 16 divided by 2, x is 8. So I have my first number. Now I need to find my second number, and we get 4. So the two numbers are 8 and 4. And you can kind of check that logically. Do 8 and 4 add to 12? Yes. And do 8 and 4 subtract to 4? Yes. So we are good there. Let's go to the next page. The school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 the second day by selling 3 senior tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. Okay, that's a lot of words. So he's selling tickets, and on the first day, they sold 3 senior and 1 child ticket for $38. On the next day, for $52, they did 3 senior and 2 child tickets. Now we're finding the price of the senior ticket and the child ticket. So the variables are the price of a senior citizen ticket and the price of a child ticket. Those are the two unknowns. And again, you can use S and C, or you can use A and B, does not matter. So we're saying that in this problem, 3 senior tickets that cost X amount and 1 child ticket that costs Y amount has a total of, or costs a total of $38. Then on the next day, 3 senior tickets that cost the same amount and 2 child tickets that cost the same amount as the previous day is a total of $52. Now I have my 2 equations, and I can choose a method. For the sake of doing something, I really want to do elimination because that's my favorite, but for the sake of doing something different, I'm going to use substitution. So what I did here is I subtracted 3x over. And then now what I'm going to do is take this and plug it in for y. Just to kind of review substitution. So I have to plug it into the next equation because if you plug it back into itself, it doesn't work out. So it's going down into this equation where y is this stuff. And we're going to solve. Distribute. Hopefully I multiplied that right. Then these are like terms right here. We're going to solve. So x is 8. Now I'm going to use that and sub it in for x to get y. And we get 14. So the senior citizen ticket cost $8 and the child ticket costs $14 because I had defined my variable y is the child's ticket and x is the price of the senior citizen ticket. So that's where I got those. That is all I have for this lesson. So if you have any questions, please email me and let me know. I'd be happy to help you.